Planes. So let's go ahead and get started. Our learning target is, I know the relationship between planes, parallel lines, and perpendicular lines. So it's the same as our last video. We're just going more in depth with it. We're gonna key in on some key points that we need to make sure that we understand, and some of this stuff we have already covered, so keep that in mind as well. So getting started, first off, through any 2 points there is exactly one line. We know that as the definition of a line. So if I have 2 points, there's exactly one line that goes between both those points. Now, along with that, every point that is on this line is included in the line. So all of these points within are made up of the line itself. So that's what the line's made up of, a bunch of points. Now, on top of that, we also know the shortest distance between 2 points is a straight line. So that is also useful for us in finding distance later on. The next definition that we know is about planes. We went through this in our last video. That definition is through any 3 non-collinear points, meaning those 3 points do not lie on that line. They don't lie on the same line. Through any 3 non-collinear points, there's exactly one plane. So that's going to be a very key point for us today. We're going to talk more about this later on when we get to a couple different problems, but that's a very key point here. So again, any 3 non-collinear, meaning they do not fall on the same line, those create one single plane. And then lastly, if 2 points lie in a plane, then the line containing those points lies in the plane. Again, this is known from yesterday. If I have 2 points that lie on the plane, and I create a line through those 2 points, then all the points that lie on that line also lie in the plane. If the line lies on the plane, things that make up the line also lie on the plane because they make up the line that lies on it. So that's also known from yesterday. Just any points that lie on this line also lie on the plane. That's all that is. All right. These two may be somewhat new to us, but equally just as important. So if 2 lines intersect, so I have these 2 blue lines here, if they intersect in exactly 1 point, which is green here. So if I have 2 lines, they'll always intersect in one single point. The other definition that we have is if 2 planes intersect, then they intersect in exactly one line. Now this is very important for us to know. Anytime that 2 planes intersect, they intersect in one line. The reason for that is because we know that planes continue out forever. They never end. They keep going outward. They're flat, which we all learned about that yesterday or in the last video. Now, on top of that, if these planes go on forever, that means that they never end. So therefore, their intersection will never end either. So that means that this isn't going to be a line segment for their intersection, but an actual line, because, again, they continue forever. So if 2 planes intersect, these purple planes, they'll intersect in exactly one single line, which is drawn with this red line here. Now, next up, go ahead and give these a try. What they have is a description over here, so they're going to describe something to you. You need to find an example in this figure of that description. Pause the video if you'd like so you can go through these, and then you can resume to go right through them with me. All right, so looking at this, the line of intersection of 2 planes. Well, we have 2 planes here. We have plane F. It has this fancy letter in the corner, which signifies that this is a plane in itself. And I can call this plane F if I'd like. We also have plane N, same type of thing. N's in the corner, it's not associated with the point, so this is the name of the plane itself. Now, the line of intersection of 2 planes, they're telling us right now 2 planes intersect in a line. So we have 2 different lines here, line BD and line AC, and we need to find out which one is cutting, or which one is causing the intersection. So where do they cross? Well, if I look at this, plane F is right here, and line BD is parallel with both edges of it. Now, along with that, it looks like plane N goes right through that as well. So therefore, the line of intersection of these 2 planes would be line BD. Now, you can also name it line BC or CB or DC. Lots of different answers for this, lots of different configurations, but we need to know that it is this line right here. Next, the point of intersection of 2 lines. So again, we're going to be looking for 2 lines. So I see that we only have 2 lines here. And with this, we want to see where they intersect. Now, looking at this, we can see that they intersect at point C, So that would be our answer. Point C is where these two lines intersect each other. There are no other lines up here, so that leaves us with only point C as the correct answer. Next, we need 3 coplanar points, meaning they lie on the same plane. So, choose any 3 points that lie on the same plane. It could be B, D, and E, C, D, E, D, and B, C, A, and D. Lots of different choices here. I didn't even write them all out, but here are quite a few just for you guys. So, any combination of 3 points that all lie on the same plane. Now, I couldn't do A, E, C because A and E are not on the same plane, so they're non-coplanar. But I could do A, C, and B because those are coplanar. So, lots of different choices, just don't combine A and E. Then lastly, 3 collinear points. So these are 3 points that lie on the same line. Now if I look at line AC, I only see 2 points here. If I look at line BD, I see 1, 2, 3 points. So those 3 points would be B, C, and D. Those are our 3 coplanar points there, B, C, and D. All right, let's go ahead and move on. Pause the video if you'd like and try this one out for a minute, and then we'll go through it. Okay, so looking at this one. First off, the line of intersection of 2 planes. So again, we have 2 different planes here, plane B and plane J. So we want to see where they cross each other. Now again, they're telling us it's a line, which is correct, because anytime that we have 2 planes intersecting, they will intersect in the line. So therefore, our answer should be line FJ. I can also say it's line FG, or line JG, or I can even call it line M, because there's this little M over the top. Same with this line over here. I could call this line L down the road. Now, the point of intersection of 2 lines. So again, we have line M and line L. Those are the only 2 lines that are shown here. I'm not going to count the top or the tops of the planes or the bottoms of the planes, because again, these go on forever. So there's no actual bottom here. So the point of intersection of 2 lines, that would be point J. Now, would points F or G also work? So F is right up here, G is right down here. Well, no. Those wouldn't work because these points are set there. They're not going to move at all. However, the planes, as we said a little bit ago, those planes continue to extend forever. So therefore, this isn't actually a line. Neither is this. These are just the tops of what we can see of the planes, but again, they continue. They don't end. So therefore, no, we cannot use points F and G. Next, we need 3 coplanar points, meaning they all lie on the same plane. So there's quite a few options for this. I can see points F, J, and H are coplanar, points G, J, and H are coplanar, points G, F, and H are coplanar. There's lots of different points here that are coplanar, pretty much any combination of the 3, because they all lie on plane J. H is the only one that does not lie on plane B, so all 3 of these points would be on plane J. And then if I chose F, J, and G, those 3 points are actually on both plane B and plane J. And then lastly, 3 collinear points. Well, there's only one line that has 3 points on it. That'd be line F, J, and G. Those 3 points would create those collinear points. So points F, J, and G. Let me go ahead and make this a little bit brighter. F, J, and G, those are the 3 points that are collinear, meaning they lie on the same line. All right, let's go ahead and move on. I'm going to cover one more thing that we've already talked about multiple times today. But again, it's so important that I want to make sure that we cover it one last time. So, if 2 planes intersect, then they intersect in exactly one line. That is something that we already know, it's something that we keep covering, but again, it's super important for us to know this. So the 2 planes intersecting will always result in a single line. The other key point here is through any 3 non-collinear points, there's exactly 1 plane. So we know that if we have 3 collinear points, the only thing that they can create is a line. The only thing that they can create is a line. However, if I have 3 non-collinear points, well, those 3 non-collinear points will create a single plane for us to use. So 3 non-collinear points is a single plane, but it also creates other things for us. It can create a triangle, right? It can create 3 vertices of a triangle. It can create 3 angles, and then also the plane. So again, lots of different things can occur from 3 non-collinear points. If I have 3 collinear points, only one thing can really happen with those, and that's a line. Now you may be saying, can I create a plane out of 3 collinear points? No. They need to be non-collinear in order for us to create a plane. If I just have 3 collinear points, that's not enough to create a plane. They need to be non-collinear. Very important. All right. Go ahead and take a second, try these out if you'd like, and then we'll go through them. So looking at this, number 21, name 3 collinear points. So lots of different answers here. So if I'm looking at this figure in the top right, I'm going to start looking for lines because we want collinear points. So if I see this line here, I start looking for 3 points on it. Well, we have points P, R, and T. Looking at another line, I see that we also have Q, R, and S as 3 collinear points. Then lastly, we also have S, T, and U as 3 collinear points. So there's 3 options that you can choose from here. I just named all 3 of them just to make sure that you guys have all the answers there. Next up, they ask us about linear pairs. Well, a linear pair is a pair of angles, that create, guess what they create? A line, because it's a linear pair. So it's a pair of angles that create a line. Now, how many things are in a pair? Well, I could have a pair of socks and a pair of ears and a pair of eyes. There's 2 per pair. So it's 2 angles that create a line. Now looking at this, if I look at angle PRQ, is there another angle that I combine with angle PRQ in order to create a straight line? Well, yes. Yes, there is. There's angle QRT. There's also angle PRS. So the purple angle and the green angle are a linear pair. The purple angle and the blue angle are also a linear pair. Now I can also see angle SRT. So I can say, oh, this blue angle and this yellow angle are a linear pair as well. So there's lots of different combinations. In fact, I can even see it right here. Angle STR and angle UTR. Those are also a linear pair. So there's quite a few linear pairs that you can choose from. It's totally up to you. I can also say that the green angle and the yellow angle, those are a linear pair as well. So lots of different choices to choose from. So I have angle PRQ, angle QRT, and then there's multiple others that we can choose from as well. Now, next we are going to explain the error in each statement. Doing so will help us out for our tests because they will be asking you guys these and we need to pay attention to the details. Because if we don't, we're going to make some errors here. So first off, 2 planes can intersect in a single point. Well, we know that's false because 2 planes, and again, we're dealing with planes here, 2 planes intersect in a single line, not a single point. This needs to be a line. So therefore, that's the error. 2 planes intersect in exactly 1 line. Number 24, 3 points have to be collinear. So if I have 3 points, they're saying that they have to be collinear. Well, that's not true because I can have 3 points that are non-collinear. In fact, it actually creates more stuff for us if I have 3 non-collinear points. So 3 points can form 3 non-collinear points. Let me be certain of that. 3 non-collinear points can form an angle or a vertice of a triangle or a plane. And again, it's key that it's 3 non-collinear points, meaning they do not lie on the same line. So again, they don't need to be collinear. Points don't need to be collinear. If they are, they can create a line for us though. The last one, a line is contained in exactly 1 plane. Well, we talked a little bit about this yesterday. If I have a plane here, draw a plane in black, and I have a line. Here's my line, and it's going through my plane. It's crossing through my plane right there. Well, what do I call this point? Well, if we recall from yesterday, that's called a foot. That's the foot of the line. It's the foot of the line on plane, whatever this plane is called. Let's call it M again. So that's the foot of the line on plane M. So is this line contained? Does it lie on top of the plane? Well, no, this line is going through, it's intersecting the plane. So it doesn't need to be contained. Lines don't need to be contained within a plane. They can go through planes, and they can also lie on them being contained if they would like. But a line can go through multiple planes if we would like it to. It doesn't need to just go through one, and it doesn't need to be just contained by one either. It can go through multiples. All right, let's go ahead and move on. Next up, explain why photographers often use a tripod when taking pictures. So think about this for a minute, pause the video if you need to, and then I'm going to explain through it in just a second after you do some thoughts. So, the idea of this goes back to the definition of a plane. For a plane, I need 3 non-collinear points. Now, if I think of this tripod as 3 non-collinear points on the ground, let's see, let me get that in there, 3 non-collinear points on the ground, well then these 3 points here are just creating a plane. Now, if we think of the Earth's surface as a plane, I mean, I know that's not flat, there's depth to it, right? And I know that I'm not a flat earther, we're on a sphere. So if I think of it as a plane because it's so large that it seems like it's flat to us who are standing on it, then we can think of it as such. So if I have 3 points, that makes up the tripod, that makes up the 3 legs here. If I add a 4th leg, that creates a 4th point for us. Now, I know with these 3 initial points here, these 3 red points, those 3 red points create one plane. As soon as I add that purple point, I can create another plane with these green points. So that's a 2nd plane. Well, I can create another plane with these purple points. There's a 3rd plane. You see what's happening? I can create many more planes with this. Here's the next one. And as we can see, it continues getting larger and larger. Actually, this next one would have to be blue over here. So there's a 4th plane. So as soon as I add a 4th point or a 4th leg, all of a sudden I'm dealing with more than one plane. However, if I want to be solid on the ground, I want to treat it as a single plane. So having 3 legs here will cause the most stability because I'm only dealing with one plane if I only have 3 points. As soon as I add this 4th leg, then this starts wobbling more so because I got to deal with 4 different planes instead of the single one. So that's why. Through any 3 non-collinear points, there is only one plane, as shown with this black plane here in the 3 red dots. So, the feet of the tripod are always flat against the plane of the ground, which steadies the camera. As soon as we add that 4th leg, that 4th point, it starts becoming more wobbly because we're dealing with more planes. Alright. Go ahead and try this one out for a second. Pause the video if you need to, and then we'll go through it. So, it wants us to name the plane that is represented by the bottom of the box. So if I look at the bottom of the box, it's this plane right down here. Now again, I need 3 points to name a plane. Don't use 4 points, just use 3. Or if it has a fancy letter, say that there is an M in the corner here, I can just call it plane M. But since that's not there, I got to use my points. And with planes, I always must write out plane beforehand. So therefore, I'm going to call this plane FGC. So plane FGC is down here. I could have called it plane BFG, BCG, lots of different answers for these, but they're all the same plane. It's this blue plane out here. Next, name the plane that is represented by the left side of the box, so over here. So the left side of the box, again, we have 4 points. Choose any 3. This would be called plane ABF. You could also call it plane AEF or plane AFB. Again, lots of different answers for this. And then lastly, name the intersection of the right side and the top of the box. So here's the right side, here's the top. The intersection should be right here where they cross. Well, again, we're dealing with planes, and I want to really drive that home, so therefore this would be line HD or line DH, up to you. Now you may be like, well, that's a segment, isn't it? It ends. But again, we're dealing with planes, so we're going to think of it as a line. If we are working within the real world and you're designing boxes and whatnot, then of course it's going to be a segment and it's going to end. but for right now, let's really drive home the point that planes intersect in a line. All right, last up, try these two, and then we'll finish up today's lesson. So, for this one, name the intersection of plane EHG, the top, and plane FGC, the right side. So again, it's intersecting of two planes. They should intersect in lines, so it should be line FG or line GF. Up to you on your notation for the line. Then lastly, name the intersection of plane ADC, so here's ADC on the bottom, and plane EHG, which is on the top. Will these two planes ever intersect each other? Well, no. So therefore, there is no solution here. They don't cross, they will never touch, so there is no solution for the intersection. All right, we have now finished up today's lesson. If you guys need anything from me, please let me know. Other than that, have a great rest of your day. Thank you guys for watching.